Now, this lesson is going to be very important for you if you want to score good marks in the numericals. In the numericals of which topic? Of punching press. Of punching press. Okay. As we know that it is a topic in the unit of flywheel and turning moment diagram. We have already covered all the flywheel and turning moment diagram concepts, the graphical questions also, many of the solved examples also have been covered. But this lesson is specifically dedicated to the concept of calculating maximum fluctuation of energy. Maximum fluctuation of energy. Now, this is also something that we have covered. I have told you how you can calculate maximum fluctuation of energy, and everything, every numerical as well as theoretical concept needed to solve the graphical problems of turning moment diagram are already covered. In this particular lesson, still, I am talking about maximum fluctuation of energy. And in this case, I am going to tell you, in this lesson, I am going to tell you how you can find out maximum fluctuation of energy for for non-graphical cases of punching. So we are not going to discuss the graphical turning moment diagram in this lesson, rather the non-graphical questions where a problem from punching press will be given to you. Some of the data will be given, any particular thing will be asked to you. Generally, they ask about the motor's power, how much power the motor is going to give, or they ask about how much is going to be the mass, the minimum mass of the flywheel, and some other parameters are asked. We are anyway going to cover solved examples in detail on this case, so we will cover all of them in subsequent lessons. But in all of those lessons, or in general, I will say, in general, in the unit of flywheel and turning moment diagram, maximum fluctuation of energy plays a very important role, right? I don't think I need to repeat the role of maximum fluctuation of energy again. We have discussed that already. So let's start the video. And the lesson that we are going to get in this video, take it very sincerely, because whatever I am going to tell you in this lesson is Exergic exclusive, which is not to be found in any other book, in any other source, in any other course. Okay? This is something which you will learn after solving many numericals. But I am telling these concepts to you directly so that you do not face any problem in solving whatever type of numerical is given to you from punching press. So let's start. In this lesson, I'm going to share with you three ways of finding out the value of maximum fluctuation of energy for punching press when graph is not given to you, when question will has not given you any turning moment diagram. It has just given you some text regarding the maximum or minimum speed of flywheel, regarding how much time will be taken in the cutting, or question may give you that how much energy is required in the cutting, how much is the power of the motor. All these things may be given to you in the question, and some of the things will be required. And trust me, if any good question comes, there is a very good probability that you have to find out delta E max, because if you want to use the expression delta E max is equal to half I omega max square minus omega min square, or the other form of the same equation, which is I omega mean square coefficient of fluctuation of speed. Any of these cases, in any of these cases, you see you have maximum fluctuation of energy. And these are some of the most frequently used expressions in this unit. In order to explain them in detail, I am going to repeat what I have taught you already about the role of flywheel in punching press. Look, since I have taught this once already, so I will not be teaching that in detail, but I will just brief you about what is the role of flywheel in punching press and how the operation is going on here. Look, the flywheel is rotating, and suppose it is rotating like this, it is rotating clockwise. Okay. At point A, it is making an angle, it is making an angle of theta from the horizontal. This is horizontal, this is point A. this is the angle theta which it is making from the horizontal. Okay, now when it is at point A, the cutting tool or the punching tool or the riveting tool that we have is just starting to do the machining operation. Okay, and as it keeps on moving, it reaches point B, right? The point B is making an angle theta 2. The point A was making an angle theta 1 from the horizontal, and point B is making an angle theta 2 from the horizontal. And when it reaches B, when this, you can say, crank or the flywheel, it reaches B, then the cutting tool finishes the operation of cutting. It can be punching, it can be riveting, it can be shearing. Any process can go on, any machining process can go on here. So from A to B, basically, the machining, the punching is happening. We know that energy is maximum before the operation. So at A, the energy is maximum. And as the machining is completed at B, so at B, energy is minimum, right? And since it is rotating clockwise, obviously a time will come when it will rotate and complete its rotation such that again it reaches at point A. What it means, that if it moves from point B to point A again, its energy should also increase from minimum to maximum. Now, from where is that energy going to come? Obviously, from the motor, right? We have a source, we have a source of constant energy, which is given by the motor. So, during this rotation from B to A, flywheel is continuously receiving the energy from the motor, which is getting stored in the flywheel in the form of its kinetic energy. So, automatically, its energy is going to get increased, its speed is going to get increased. So as it moves from B to A and it reaches at point A, its energy will increase from minimum to maximum. What is the maximum fluctuation of energy? You tell me. I'm discussing the first way right now. What is the first way to know the maximum fluctuation of energy? We know that maximum fluctuation of energy is equal to maximum energy minus minimum energy. And how much is maximum energy minus minimum energy? How much is the difference between them? The difference is equal to how much energy the flywheel has received from the motor during this cycle when it moves from B to A. Suppose the minimum energy was 10 kilojoule, the maximum energy was 50 kilojoule. So how much energy motor has given to flywheel when it moved from B to A? Its energy increased from 10 to 50. From where does the remaining 40 kilojoule came? Obviously from the motor. So basically motor has supplied it 40 kilojoule, or motor has supplied it E max minus E min, or motor has supplied it the energy delta E max, or maximum fluctuation of energy. So we can clearly say that the energy provided by the motor from B to A is nothing but Emax minus Emin, which is maximum fluctuation of energy. At the same time, we can also say that energy provided by the motor from B to B, or from A to A, or in one cycle, in one complete cycle, is equal to how much? Is equal to energy required for cutting. Now this is again a concept which I have already told you, and to be very honest, we are not going to use this concept in this method. I'm going to tell you three different methods, three different ways. In this method we are not going to use this concept, but since it is going in sync with this statement, energy of motor from B to A, so I just thought of reminding you that how much is the energy of motor from B to B, or from A to A, or in a complete cycle, that is equal to energy of cutting. Since we have discussed this expression once earlier, and we will be using and discussing this once more in the second method, so I am not discussing it right now. Okay, it is something that I just shared, which was going in rhythm with this first statement. So coming to the first statement, that the energy of motor from B to A can be called to be equal to maximum fluctuation of energy. Now, suppose the question has given you that the motor has P kilowatt rating. What it means is that if motor has P kilowatt rating, it means that it is generating or it is giving as input energy of P kilojoule per second to the flywheel. So if in 1 second motor is giving an energy of P kilojoule, and suppose the time taken in moving from B to A was 10 seconds, suppose 10 seconds. So how much will be the energy given by the motor to the flywheel? 10 P kilojoule, 10 P kilojoule. And that energy, as we know, is nothing but maximum fluctuation of energy. So if the power rating of motor is known, and the time taken by the flywheel to move from B to A is also known, you simply have to multiply them together and you will get the maximum fluctuation of energy. Now, things may not be this much simple in every case. Why do you think I am telling you three different ways? These are not taught anywhere else as three ways of solving. This is the only place where you are going to see this. Why? Because the type of problems that can be asked from punching press can be of different types, right? There can be some problems where you cannot apply the first way, because the data given to you in the question will be totally different, where this cannot be used. In some of the methods, even the second way will not work. But if you know all three ways, trust me, there will not be even a single question from punching press that you will not be able to solve. Mainly if you have to calculate maximum fluctuation of energy. Any other concept, obviously, we are going to discuss in the further lessons and further examples. But as far as calculation of maximum fluctuation of energy is considered, these three ways are going to open your mind to whatever type of problems are going to come in front of you. That is why it is possible that the simple funda that I have told you, may not work everywhere. And we are going to see that what to do when it does not work, what data can help us. Let's complicate this problem. Here I assumed that it is given to us that in moving from B to A, it takes 10 seconds. But trust me, it will not be given to you in the question. You have to find it out. Now, how can you find it out? Suppose the question gave you that the cutting time is 2 seconds. Okay. Or the time taken in punching operation is 2 seconds. What does it mean? It means that in moving from here to here, in doing the punching or machining, it is taking how much time? 2 seconds. Or in other words, in moving from A to B, it is taking 2 seconds, because when it moves from A to B, the tool moves from start to the finish, right? So if question has given you that time taken of machining of punching is 2 seconds, then it means that from A to B it will take 2 seconds, right? And suppose the question also gave you that number of holes that it is creating per minute is 12. This punching operation is creating 12 holes in 1 minute. Means 12 holes in 60 seconds. Means one hole in 60 by 12 or 5 seconds. So in 5 seconds, it is creating one hole. That data can be calculated if you know the number of holes being created per minute. Again, as I told you, many type of questions are possible. Question may give you this, and it is given in many of such questions. So if it takes 5 seconds to create one hole. What does it mean? When one hole will be created? When the punch moves one complete cycle from bottom to the top, then you can say then that on average it takes 5 seconds to create one hole. This 2 second and this 5 second are different. This 2 second is exact cutting timing, exact punching operation time, which will be given to you. If question mentions that the punching operation takes 2 seconds, then take that to be the exact time of punching. So if the exact timing is 2 seconds of cutting, okay, means when the tool moves from here to here, it takes 2 seconds. And if it gives that number of hole created per minute is this much, and from that you calculate the time required for one hole, then this time and this time are different. This time is the exact time of cutting, and this time is the time period for overall movement of the tool from the top to the bottom, and then again from bottom to the top. Or I can say that in other words, it is the time taken for flywheel to complete one full revolution. It will start from the top point, from one point, it will complete one revolution. As it completes 180-degree, tool will move from top to bottom. As it completes next 180-degree, tool will move from bottom to top, right? So one hole creation, time taken to create one hole, average time taken to create one hole like this, is nothing but the time of one cycle, right? So this is the time of cycle, time for one cycle. If the time for one cycle is 5 seconds, or in other words, if I start from a and I complete one revolution and reach at a again, it is going to take me 5 seconds. And it has been given that in cutting it takes 2 seconds, or in other words, as I move from a to b, it takes 2 seconds. So can I not say that in moving from b to a it will take 3 seconds? Because one full revolution is 5 seconds, and from a to b this portion is 2 seconds, so rest rotation will be covered in 3 seconds, right or not? So time required from b to a, time required from b to a, which if you recall I directly wrote here as 10 second, that may not be given to in the question, that you need to calculate. Just like here we calculated it, 5 minus 2 is equal to 3 seconds, right? So that time was 3 seconds. So the energy received in 3 seconds will be 3p kilojoule, since in 1 second it gives p kilojoule. So 3p is your answer. The energy given by the motor in moving from b to a is nothing but the maximum fluctuation of energy. So you need to look out for such data, for data like time of cutting operation, time of punching operation, or number of holes created. They can give you number of holes created per minute or per second or per hour. You have to convert it so that you can calculate that how much time average is consumed in creating one hole, so that you can take the difference of those, this number and this number, and find out the actual time taken in moving from b to a, from minimum to maximum energy. This is one of the type of problems that you are going to face, and you can solve these problems easily by this method that I have told you. And remember, I am not going to solve any problem right now. We will separately solve examples regarding this, related to this. Here, I am just talking about calculating maximum fluctuation of energy, which is the most important parameter in flywheel and turning moment diagram unit. Now, let us see the second way in which such problems can be solved. Now, recall the concept that I referred in the first case, in the first way, that energy given by the motor in one cycle, energy given by the motor in one cycle is equal to energy required for cutting. This is something that I have already taught you when covering the theory, that whatever energy the motor gives, flywheel just passes it on, and it is used solely in cutting. If you look over a cycle, over a complete cycle, flywheel does not store any energy. Yes, it stores energy for some part of the cycle, and then it gives it back for some other part of the cycle. But at the end of every cycle, its energy does not change, its speed does not change. Whatever was its speed before that cycle, it stays the same. During the cycle, it fluctuates just like its energy fluctuates. But ultimately, flywheel is not taking any energy from the motor over one complete cycle. Whatever it receives, it passes on. It just regulate it, right? It just increase or decrease the supply as and when required. So whatever is the energy that you pass on through motor in one cycle, that is totally received here at the cutting point. And how much energy do you need here at the cutting point in one cycle? Why do you need the energy here to do the cutting? In every cycle, when the tool moves, when the punch tool moves from bottom and then to back to the top, in that one cycle, this is the part where energy is consumed in cutting. So in one cycle of it, obviously whatever energy is being used in cutting will be supplied, the same energy will be supplied by the motor. Flywheel is just regulating it in the way. So suppose question gave you the energy required for cutting. Suppose the question gave you that 14,000 joule or 14 kilojoule of energy is required to complete one process, to complete one shearing process or one punching process. Means to create one cut, this much energy is required. Or in other words, I can definitely say that in one cycle, this much energy should be provided by the motor, because motor is the only source of energy which is giving the energy for cutting, right? So I can clearly say that in one cycle, if 14 kilojoule is required for cutting, that in one cycle 14 kilojoule should be given by the motor to this place where cutting is happening. That is what I have written here. Energy required in cutting, in one cutting, is equal to energy which is given by the motor in one cycle. So suppose question gave you that 14 kilojoule is the energy required for cutting. So clearly energy, the energy given by the motor in one cycle will also be 14 kilojoule. Means if the flywheel started at A and it rotated and completed one revolution and reached back at A, then during this rotation it received 14 kilojoule from the motor, which obviously it passed on further, but it received this much energy, right? So if in moving from A to A, it received 14 kilojoule of energy, how much energy it is going to receive in moving from B to A? How much energy do you think? Suppose we have been given the data which was given to us earlier, that 2 second is given in the cutting, and number of holes creation is being 14 holes per minute, and from that we have calculated that cycle time is going to be 5 seconds. So suppose these things are known to us in the question, so you can clearly see that out of the complete rotation from A to A, out of this total cycle time, 2 by 5 time, 2/5 time is spent from A to B, right? Actually this should be little bit larger because it's two part if we divide the circle in 5, but just forget about the distance that I have shown between A and B. Just assume that A to B takes 2 seconds and A to A takes 5 seconds. So if that is the case, as per the data given to you in the question, then 2 by 5th time is spent in moving from A to B, and rest 3 by 5th time is spent in moving from B to A, right? And if in moving from A to A, it receives an energy of 14 kilojoule, because 14 kilojoule is the energy required for cutting. So 3/5 of that energy is going to be used. 3/5 of that energy is going to be used in moving from B to A. A to B will require 2/5. B to A, in the clockwise sense we are talking, will require 3/5 of the time, right? And since the energy given by the motor is constant, it is not varying, it's a constant value, every second it is giving p kilojoule, right? So when it moves from B to A, it takes 3/5 time of completing the full cycle, and in that 3/5 time it will receive 3/5 of the total energy. And as I told you, how much is the energy of the motor in one cycle? It is equal to energy required for cutting, energy of cut, right? And this is something that question will give you. So you can directly put that value here, directly put the value of energy required for cutting here. These values obviously you have to calculate from the given data, and then you will be able to know that how much is the energy that it is going to get in moving from B to A, and that is nothing but maximum fluctuation of energy. How much energy it receives when it moves from B to A. E max minus E min, difference of them is delta E max. So this is the second way in which you can calculate the maximum fluctuation of energy. Don't write 3 by 5 in your final expression. It will depend upon what is given to you in the question. And Trust me, when all this data is given in the question, now when the question gives that time of cutting is 2 seconds, number of holes is this much, and the energy of the motor is this much, when all these things are given, students in exam pressure they confuse if they don't know these different ways categorized differently. If you just understood the concept, which I think everyone does, nobody is competing in gate in top 1000 or top 2000 or 5000 without the concepts. They already have the concepts, all of them have it. But how to apply those concepts, how to apply those concepts in solving numericals under pressure, is something for which you need to prepare. And knowing these ways clearly is going to do that for you, is going to help you in such questions. Let's talk about the third way now. The third way that we are going to discuss is one of the most easy and direct way out of all the three methods that we have discussed. Look, we know that the energy given by the motor during A to B motion is not sufficient for cutting. That is why we require the flywheel. If that was sufficient to do the cutting, why will we require the flywheel? We require the flywheel so that when cutting is not happening, it can store the excess energy, and that excess energy, that extra, that additional energy can be used in cutting when it is moving from A to B. Because during A to B, if we depend only upon the motor, then motor gives only a fraction of energy during A to B, which is not sufficient. Although, for one complete cycle, as we just talked about in the second method, that for one complete cycle, the energy provided by the motor is sufficient to do the cutting. Rather, it is equal to the energy required for cutting. But since it provides energy not in batches, not in pulses, but continuously, continuously provides energy. So that energy which is required for cutting is not only being provided from A to B, but that is distributed throughout the cycle. So flywheel just redistribute that energy. It stores some energy out of that when it is not doing the cutting, and that energy it gives back when the cutting is happening, so that total energy of the motor which was distributed throughout the cycle can be used only during A to B and cutting can happen. Okay, so we know that energy required for cutting is equal to energy given by motor, right, during A to B, during A to B, because cutting is happening only during A to B, plus whatever energy the flywheel collected from B to A, that is going to come here, right? So energy collected by flywheel from B to A. The thing to note in this expression is that this is not the energy of motor per cycle. Don't think that this is energy of the motor per cycle. If this was energy of the motor per cycle, expression would have been this, that the energy required for cutting is totally given by the motor in one cycle. That is what I have already taught you. Whatever energy motor gives in one cycle, total energy is used in cutting. Flywheel does not store anything. So don't think that the expression here, the expression that I have written here, in this expression, E of motor is not energy of the motor per cycle. Rather, it is the provided energy provided by motor during cutting, only during cutting. Okay, which is less than the total energy required for cutting. So the rest is compensated by that energy which motor gave during cutting was not happening to the flywheel, right? And we know that how much is that? E B to A, energy that is collected by flywheel from B to A. What is that? It is nothing but maximum fluctuation of energy. So, can we not say that maximum fluctuation of energy is equal to energy of cutting minus energy of motor, energy given by motor during cutting? Definitely, we can say it. Energy of cutting, it can be given to you in the question as I told you. So, let's say it is known to us, which is 14 kilojoule. It is given to us that energy required to create one cut or one cutting operation or one punching operation or one shearing operation is 14 kilojoule, minus how much energy does the motor give during this time, during the cutting. There are number of ways to know that. We have discussed those ways, right? If somehow you have been given in the question that 2 second is the time of cutting, and you calculated that 5 second is the time of cycle, right? So you can clearly know how much is the energy given by motor in cutting. Tell me, what should we write here? In 1 second, motor is giving p kilojoule of energy. This is the energy of motor during cutting. Cutting is happening in 2 seconds. In 1 second, this much energy is required. Connect those three data. In 1 second, this much energy is required. Cutting is happening in 2 seconds. And this is the energy of motor during cutting. So it should be 2p, isn't it? Value of p will be given to you. You can calculate maximum fluctuation of energy. And trust me, there are more ways in which this 2p term can be reached. And that is why, if I start telling you the number of ways to solve these questions, I can tell you 10 different ways of solving them, because I can frame 10 different types of questions from punching press. But if you have understood these three ways, these three different categories in which the maximum fluctuation of energy can be calculated, then trust me, you will not find any problem in calculating the maximum fluctuation of energy for any of the cases. There will be some good questions where you may struggle a little bit, but don't worry, we are going to discuss those cases in detail in the solved examples. But as far as calculating maximum fluctuation of energy is required, you will not face any trouble in punching press numerical after this. Non graphical cases, I am telling you. Graphical cases I have already discussed in detail with you. I'm sure you have understood that and you are able to solve all questions from that. Now let's move ahead and solve some high quality examples.